Good day, I'm your host Mwanza. In this presentation, we are going to answer Science 2024 Paper 1. Question B. Figure B2.1 shows a wheel and axe for a simple machine used to lift a load of 240 Newton when an effort of 60 Newton is applied. So here we have this question. So here we are told that this question is from what? A simple machine. And we know when you talk of a simple machine we say it's a device that makes work easy. Those are simple definition of a simple machine. Or a simple machine, it is a machine or a device that uses less effort to overcome huge load. As you can see here, we've got less effort and the huge load. Okay, so now here we have this part of a simple machine, which is wheel and axe. So here this is wheel and axe. We've got the big ledgers and the small ledgers. Then effort 60 Newton and the load 40 Newton. So just try to explain on this load and effort. When you talk of load, the load, we say it is the force that is being overcome by effort. So the force that is overcome by effort, it's one that we call load. Now when you talk of effort is the force that overcomes the load. Okay, the force that overcomes load. So under simple machine, we have two different forces. Question, the first one here, define a simple machine. So now to define a simple machine, we said that a simple machine is a device that makes work easy. So now here on this one, we just like this one. A simple machine is a device that work with one movement and change the size and direction of force. A simple machine is a device, the device that work with one movement and change the size and the direction of force. Okay, so here we have different types of definition of a simple machine. A simple machine is a device that work with one movement and change the size and direction of force. Then, or you can also define a simple machine as a device that makes work easy. The device that makes work easy. When you talk of these simple machines, we are saying that we've got different type of simple machine that makes work easy. We have the first one, which is this one, the wheel and axe. We also have the pulley system, which is also a simple machine. We also have an inclined plane, to mention but a few. Those are examples of what a simple machine that we will try to discuss. Then let's see, answer the second one. Calculate the mechanical advantage of the wheel and axe shown. So this is the wheel and axe. They want mechanical advantage. So here mechanical advantage is load over what? Effort. Load over effort. So mechanical advantage tries to explain the number of times the load is greater than the effort. So this one, the mechanical advantage, like this, is equal to load over effort. Okay, here our load, we have the load is what? This one, 240. So you don't even need to panic. Everything has been given here. It's 240 N. Then we have our effort. So over effort, which is 60 N. So this N Newton and this Newton will do what? Will reduce to 1. Then you have here 0, 0, it will go. How many times can 6 go into 24? So 6 into 24, I'll write it here. 6 into 24, it's 4 times. So this is our answer, 4 times. So here the answer is 4. So mechanical advantage, therefore the mechanical advantage here, MA is equal to 4. Mechanical advantage has no units. Okay, see, if the radii of the wheel R and axe R are 80 centimeter and 16 centimeter respectively, determine the velocity ratio VR of the wheel and the axe. So here we are told that the radii R, this R here, this R here, it is 80 centimeter. Then this smaller one here, the smaller radii is smaller radius here is 16 centimeter. Then the question is determine the velocity ratio. So to determine the velocity ratio, which is what we call the VR, we say it's the ratio of distance moved by effort to the distance moved by load. So here we are saying that it's the distance, like D moved by effort over or divided by distance moved by load. So this is the formula. So having this formula, we know the distance moved by effort is this one here. It's this one, the capital R. Then by load is what? The smaller R. Now, having that idea, we are saying that VR here is VR is equal to distance moved by effort, okay, over distance moved by load. So here the distance moved by effort is 80 centimeter. Then distance moved by load is what? 16 centimeter. So what happens here, this unit and this unit will do what? Will cancel. So the unit and this unit will do what? Will cancel. Then 16 into 80, how many times? So 16 into 80 is going 5 times. Okay, so this is our VR. So in writing, therefore our VR is equal to, it is velocity ratio is equal to 5. So even velocity ratio has no units, Okay, so let's proceed. What is the efficiency of the wheel and axe? So here they want efficiency symbol that we use, something that looks like N, then it goes like this. So this is the symbol that we use on efficiency. So efficiency is equal to mechanical advantage, then over velocity ratio, divided by velocity ratio times 100%. Okay, so simple machines, again, we need to know that simple machines are rarely to be 100% because a lot of energy is lost due to heat and also due to friction. Okay, so here when talk of mechanical advantage, we answered to say our mechanical advantage is 4. Then our VR is what? 5. So just replace mechanical advantage here, we say it's 4. then our VRR is 5 by 100%. Okay, then how many times can 5 go into 100? So 5, there's 1. 5 into 10, it's 2. Then 5 into 0 is what? 20. So 4 times 20, it is giving us what? 8%. So this is our efficiency. So here our efficiency is what? 80%. So you get full 2 marks. So altogether the total marks is what? 7.